Hello guys, so this is our video for section 7.4. This section is about nonlinear systems of equations. Okay, so the equations in these systems, some of them might be lines, but some of them are going to be nonlinear. So they might be circles, they might be parabolas, they could be rational equations. And so what you're going to find with these systems is that a lot of times you can have multiple solutions without necessarily being infinitely many solutions. So if we look at, this is number 3, this first equation, if I solve for y, just to give you an example of what we're looking at, we get y equals 54 over x. So that's actually, I don't know what that looks like exactly, but because it's a fraction like that, I know it's some sort of rational equation. Just the fact that there's an x on the bottom tells me that. I have no idea what it actually looks like, but just to give you a clue. And then this one is linear because all the x's and y's are pretty straightforward. There's nothing being multiplied, nothing being squared. If I did solve this for y, I would get y equals 3x plus 9. So this is some kind of linear equation with a positive slope like this. So we know, based on this kind of guess of an image, this is really a bad picture, but this rough idea, there should actually be 2 solutions because these graphs intersect twice, okay? Now these problems, you're not going to have to graph these for the most part. As you're solving them, you will find the multiple solutions by using things like a plus or minus when we square root something. That's usually where the multiple solutions come in, is if we have to square root a value, we have to remember that there is a plus or minus to our answer, and that's usually how we end up with our multiple solutions. So going through this problem, and then we might do one more after this. This one wants us to use the substitution method. Okay, so we're going to use substitution for this one. So that means we want to solve for one of our variables and plug it into the other equation. Now, for me personally, I think this y is going to be the easiest to get by itself. And we had already had that just a second ago. It was y equals 3x plus 9. Okay, so you can subtract the 3x, and then you would divide by this negative, which is why the signs change. So I'm going to plug that into the y in the other equation. Okay, it plugs into the y in the other equation. So the 3x plus 9 goes in where that y was. Okay, so it was x times y equals 54. So to solve from here, we just distribute. We get 3x squared plus 9x equals 54. Okay, now anytime you see that you have an x squared and an x, that should tell you this is a quadratic, okay, as long as you don't have anything higher than x squared. Every time you solve quadratics, regardless of which method you use, you need it equal to 0 every time. People start getting confused and they start moving things like they're going to get x squared by itself. You're not going to do it that way. This is a quadratic. We need it set equal to 0. So I'm going to subtract the 54 from both sides. Okay, so we have 3x squared plus 9x minus 54 equals 0. Okay, so from here, you can either go straight to the quadratic formula, or you can try factoring. One thing you can try is if you do the discriminant of the quadratic formula, I'll show you what I mean. The part under the square root is called the discriminant. That part, if you just work that out, can tell you whether or not it's factorable. So if we just do the b squared minus 4ac, and we get a number, if that number square roots evenly, then this problem is factorable, right? So I did the square root and it was a nice whole number. So that means I can factor this. Like, it's possible to factor this. I don't have to go that route. I can just finish out the quadratic formula and I'll get my answers that way. But if you like factoring, or if you're good at factoring, it can be a little faster. So I know to factor this, I have to have a 3x and an x, okay? Because that's the only way I'm going to get 3x squared. So then my other two numbers, I'm thinking of numbers that multiply to get 54. But then when I FOIL this out, I'm going to have to end up with a 9x in the middle. So thinking of numbers that multiply to get 54, I think of 9 and 6. And I don't really know if it's going to have to be a 9 here and a 6 here, or a 6 here and a 9 here. I kind of have to play with it until I find the one that works. So I think it's a 9 and a 6, and I need negative and positive. And the only reason I know that is because I'm kind of working out the FOIL in my head as I think this through. So if I start FOILing this, 3x times x is 3x squared. 3x times 6 is the 18x minus the 9x. And that's how I get a 9x in the middle. Okay? So once you have it factored, you set each one equal to 0. And this is where you're going to get your x values. So if I add 9, I get 3x equals 9, divide by 3, x equals 3. Here I get x equals negative 6. So I've started two different coordinates, two different x values. One of them starts with a 3 and one of them starts with a negative 6. And they're each going to have their own y values. So I have to find the y values for them. I can go into either equation here and figure out what the y value should be for the given x value. So, for example, if x equals 3, 3 times y needs to equal 54, right? So you would do 54 divided by 3, and you get 18. So that's my y value that goes with 3. And then you would do the same thing with negative 6. So 54 divided by negative 6, and you get negative 9. Okay? So you get your y values that go with your x values by using either of these equations. We could have used the second equation, and it would have worked just fine. So this particular problem has two solutions. Two solutions. Okay? We're going to do one more problem. Okay, so for this one, it says to solve by the addition method or elimination. Just to give you kind of a visual, you actually haven't seen graphs like the second one before, not in this class, but we don't really need the graph. I'm just kind of giving you a visual. The first one's a circle. X squared plus y squared makes it a circle. It would have a radius of 6. Again, this is a very rough graph. The second equation is actually a parabola that opens sideways. So I know you guys have not done these. You won't get to those until the next math course, Math 172. So again, you don't need to know what this graph looks like, but I just like giving you a visual so you can kind of see what's going on. So there's some kind of parabola opening sideways. So again, we're going to have something probably with two solutions, unless the parabola is more like if it was like this, that could be one solution. Or it could be something, let's see, you could also have it more narrow and hit right here like this. And so then you'd actually have 3. So we have some different possibilities depending on what the graph looks like. But to do this with elimination, we need to line up our correct pieces. So I'm going to rewrite it. I have an x squared plus y squared equals 36. And then I'm going to space this out differently. I have the y squared lining up with the y squared minus 3x equals 36. Now, I want my y squareds to eliminate. So I'm going to multiply my second equation by -1 so that the signs are the opposite. Okay? So that actually makes it a negative y squared, a positive 3x, and a negative 36. So bringing everything down, I get x squared, y squared minus y squared, I've canceled out, a positive 3x, and it equals 0. So that's kind of interesting. 36 minus 36 equals 0. So to solve something like this, when it doesn't have that third term, we're actually going to use greatest common factor. Okay, greatest common factor. So I will factor out an x, because that's my greatest common factor, and that leaves me with x plus 3. Woo, whoa, my pen went crazy. X plus 3. Right, because if I take out an x from here and an x from here, I'm left with an x and a positive 3. So now that's what we split and set each one equal to 0. Oops, equal to 0. So I get x equals 0 and x equals -3. So that's the start of my 2 solutions, right? I'm going to have 2 solutions with this one. One starts with 0, one starts with -3. To get the y values, again, I just need to plug back into any of these. So let me use maybe the second equation. Y squared, I'll go ahead and add that 3x over. 3 times x plus 36. Oops. So I get y squared equals 36. So y equals the square root of 36, which is plus or minus 6. Oh, so that means 0 goes with 6 and 0 goes with -6. So we have even more solutions here. Okay, so let's try plugging in -3. If I plug in -3 into the same thing, okay, so I get y squared equals -9 plus 36. So y squared equals 36 minus 9 is 27. So y equals plus or minus the square root of 27. You can simplify that. If I break 27 down, that breaks down into a 9 times a 3. So we square root each of those. So y equals plus or minus 3 root 3. So give me 1 second. Okay, sorry about that. I just wanted to rewrite that a little neater. So when we used x equals 0, it came out to have 2 separate y values. So that makes it 2 separate points. And when we used x equals -3, that also came out to 2 separate y values. We had to simplify it. Make sure you simplify it. And so that gave us 2 separate points. So when we type them in, we end up with 4 ordered pairs total. So this is probably some kind of circle with the parabola going through it like this, where it crosses in 4 points. Okay? All right, hope that helps. Let me know if you have questions, and I'll see you later.